Hello everyone, I'm Jay Joshi and welcome to the 29th episode of Learning Java. Today we'll be learning about wrapper classes and the parse string functions. So first we'll be learning about the wrapper classes. So what are wrapper classes? So wrapper classes are basically classes that are present in the java.lang package, which is the default package in Java. And these wrapper classes are used to convert primitive data types to objects and objects to primitive data types. So you all know what primitive data types are, like byte, short, int, long, float, double, char, and boolean. These are primitive data types. And then you all know what objects are. Objects are an instance of a class. So these wrapper classes are used to convert primitive data types to objects and objects to primitive data types. So why is this useful? Why do we want to convert primitive data type to objects and objects to primitive data types? Well, when you're doing object-oriented programming, you'll actually see their benefits, how useful. In some cases, it's better to use primitive data types, and in some cases, it's better to use objects. So you'll see that. So for now, just learn the concept of wrapper classes. So this is the table which you need to know to learn about wrapper classes. These are all the primitive data types, as I said: byte, short, int, long, float, double, boolean, and char. And these are their wrapper classes. So the wrapper classes for byte is byte, so capital, short is short, int is integer, and so on. So what you need to know, a simple method to learn this is, for every single primitive data type, its wrapper class will be the same thing, but in full form. So for int, like it's integer, for char, it's character. So the wrapper class is always written in the full form of the primitive data type, and the first letter is always capital. So like how this B is capital over here, and so in every case, like char is character, boolean is boolean with capital B, and so on. So these are the wrapper classes. So let's see how we actually convert a primitive data type to an object. So this is the main syntax on how this example below, which I have underlined, is how we convert a primitive data type to an object. In this case, we are converting the primitive data type integer, to actually byte. So this 2 over here is a literal and it's a byte. So this 2 is of the byte data type. It doesn't matter, it's any data type because it's literal. So this can be a variable, also anything else. And we are converting this number into the byte into an object B, which is of the byte type. So you're converting this into a byte object. This can also be an integer, so it will be integer B is equal to new integer and then the variable or the literal in the brackets. So this is the basic syntax. Now I'll be showing you some more examples on BlueJ. So these are the wrapper classes. These are 3 examples of wrapper classes. So we'll come to this a bit later. Ignore this for now. We'll look at these 2. So let's say I declare an initializer variable A of the integer data type, giving it the value 10. Now this is a primitive data type. A over here is a primitive data type. If I want to convert this to an object, I have to use wrapper classes. So let's say I want to convert this to an integer object. So I can do it the same way. So this was the same way as it was in the PPT. In that case, it was byte. In this case, it's integer. So integer, and you can give this any name. New integer. So new is a keyword to allocate memory. Integer. And then the variable or the particular literal. So if I wanted, I could have put just 10 over here. In this case, we have a variable, so we can put anything. So this is how I'm using wrapper classes to convert a primitive data type to an object. And another note over here is that you don't have to like invoke this package and all for this to work because it's in the default package java.lang. Now let's say I want to convert an object to a primitive data type. So I create an object over here, y object of the integer type. So integer y is equal to new integer, and the value of y is 12. And then if I want to convert this object y to a primitive data type, I can just do int any variable is equal to y. So now this primitive data type int z is going to store the value of the object integer y. So this is how you convert an object to a primitive data type, and this is primitive data type to an object. And you can perform any function using these object primitive data types. You can print them. Let's say this y is just a normal integer variable. You can do anything with them. You can print them, perform operations on them. It's all fine. It's kind of like a primitive data type only. Now, another function which we have in wrapper classes is how we convert a integer to a string. So let's say we have this integer over here. It can be an object or a primitive data type. So this can be either y, z, or a or x. So we need to use the .toString function. Now this .toString function is again in the wrapper class, and it's in the java.lang package, default package, so you don't need to invoke any other package. So this is the basic syntax. So this is the string s I have over here, and the value of the string will be the same value. So let's say this y right now has the value 12. So this is this s is going to store, the string s is going to store the value 12, the value basically of the object y, in the form of a string, which can be useful in many cases. So use the .toString function to convert an integer to a string, .toString. So that is basically it for wrapper classes. There's nothing much to cover in it. It's a very simple and basic concept. It's just the conversion of primitive data types to objects and objects to primitive data types. This is the basic syntax you have to learn, and this is the conversion use of a primitive data type or object to a string. That's how you do it. Now you might ask, how do I convert? Is it possible to convert a string to an integer? Let's say I have a string which has the value. Let's say I have a string s2 is equal to, 1 2 3. Let's say it has this value. What if I want to convert this string into an integer? How do I do that? You already know how we can convert an integer to a string using the .toString function. You can even convert an integer to a string using something like this. So string s3 is equal to null plus whatever value, let's say z. So z is an integer, so you can convert an integer to a string this way as well. So any method is fine, the .toString function, the s3, anything is fine, it's all the same. Now let's say I want to convert a string to a integer or any other data type. Let's say I just want to convert a string to a number, like any number from byte, short, int, long, or double or float. How do I do that? Or even to a character or boolean. How is that possible? Well, to do that we need to know about not wrapper classes, we need to know about the parse string functions. So here we have parse string. So what is this parse string? Parse string is basically a function we use to convert a string to any other data type. So how do we do that? Let's say we have a string 1 2 3. Now I can convert this string to a integer by using this integer.parseInt. This is the line I have to learn to convert a string to any other thing. So let's say so I'm storing the value of this string. So the value of string s is 1 2 3 in string form. So I can convert this to an integer, right? Because it's an integer value. So to convert this to an integer, I do int a wherever I want to store it. Integer.parseInt, notice the capitalization, this I and this I is capital, and then s in the bracket. Now let's say the value of the string was 1 2 3 s. Let's say this was the value of the string, and if I try to convert this to a integer using the parseInt, this won't work, because if I convert this to an integer, this s won't get converted to an integer, so that's not possible. So it'll throw an error. So it'll only work if all this is a number. Now let's say I want to convert this to double, so I can use double d is equal to double.parse double. It's all the same. Let's say if I have a string, let's say the value of s is something like a, which is a string, right? Now I want to convert this a to character. How do I do that? We can do something like this. So instead of this double, we can have something like char. Over here, instead of double, we can write character, ch. You have to write the full thing with c capital, character, and then dot parse will remain the same, and then instead of this double, we have to just put char. So char d is equal to character dot parse char, and then you convert this to a string. And let's say the value of the string is something like either true or false in string form. We can use something like boolean b is equal to boolean dot parse boolean and then s. So this is how you basically convert a string to a primitive data type. This is very useful in many programs, especially this integer double float conversion and things like this. You can use things like byte b is equal to byte.parse byte and then s, whatever the variable of the string is. You can just put the string directly over here. I can just put like this inside these brackets, like this is a literal string. So I can put it like that, it really doesn't matter. So this is how this particular parse string is very useful in our programs, and you have to learn this basic syntax to implement it in your codes. Now I'll be showing you a quick example of how you can use this parse string function in your program codes. Let's say I want to write a program code to find out the sum of the digits of a number. So I ask the user to enter a number. Let's say they enter any number like 374, and I want to calculate the sum of the digits of the number. So for 374, the answer will be 14 because 3 plus 7 plus 4 is 14. So how do we do that? Well, if we didn't know all this integer, this parse string function, we could have done it in a way like this. So we use the arithmetic functions, arithmetic operators, the mod and the division to get the value of each of the things. So the code will be something like first we find out the number of digits in that particular number, and then we keep using mod division to find out the final letter and keep adding it to a variable sum. Now this can be a very tedious method, so the faster method of doing it is using the parse int. So this is a very small code to find out the sum of a number, sum of the digits of a number. So I declare scanner sc and I ask the user to enter a number, and the number gets stored in the variable n. I use this math function n is equal to math.absn just to show you an example of how we can use the math function so as well. This abs finds out the absolute value of the integer n. So basically if the user by mistake enters a negative number, it just converts it into a positive number. If you don't know what this math.abs function is, you can check out my video on math functions in which I cover all the different types of math functions. There's not a compulsory line, it's just a good line to have. So it's basically just a precautionary line kind of a thing. Now I have a variable sum, integer variable sum, to calculate the sum of the numbers. This is where I will store the sum of the digits. Now I'm converting this n number integer into a string, and I'm storing the string equivalent of the integer n into string s. So I'm doing it by using something like this. An important point to note is that if you do something like n plus something like this, or although it's being compiled, something like this won't really work. So you have to do it the other way around. It needs to be like this. This is how the compiler goes, because it goes from left to right, so it adds a string to the number. It can't add a number to a string. Now this is the main part of the code, the for loop. So the value of n is stored in the string s. So I'm running a for loop in which I'm using the variable I. The initial value of I is 0 because the string indexes start from 0 till 1 minus the length of the string. I should be less than s dot length because again it's less than, not less than, equal to, because the final index of the string is 1 less than the length of the string, and then I plus plus. A simple for loop. And now to calculate the sum, I do something like this. Sum is equal to sum plus integer.parseInt s.substring I comma I plus 1. Now let me explain what's happening over here. This looks a bit complicated, but it's a compact code to find out the sum of the digits of the number. First we look into this. S.substring I comma I plus 1. So let's say I have a number, let's say I have the 347 number, right? I have this number which is stored in string s. The current value of I is 0, and it goes on till it's less than the length of the string. So the length of the string is 3, I is currently 0, so 0 should be less than 3 basically. That's the condition. Currently the value of sum is 0. So the first iteration, so first we look at s.substring. So since it's a substring, so the value of I is 0 should be 0 comma 1. So s.substring 0 comma 1, I plus 1, 0 plus 1, 1, 0 comma 1. This is the 0th index, 3 is the 0th index, 4 is the first index. So the value over here will be string 3, because substring, again, if you watch my string functions video, only includes, it does -1 over here. So it only includes this particular variable. So now what our thing is basically integer.parseInt, and then we have 3. Now this integer.parseInt converts 3 to an integer, and then we just do sum plus 3. So what is the sum right now? It's 0 plus 3. So currently the value of sum is 3. Now it goes on to the next iteration where the value of I is 1 and I is less than 3. So this condition is true. It goes over here in this again. So it does sum is equal to sum. So sum, the current value of sum is 3. 3 plus s dot substring. I is currently 1. So 1, this is the first, next, comma 2. So 1 comma 2. So the value of this s dot substring 1 comma 2 is 4. It converts the 4 to an integer, and then it's sum plus 4. So 3 plus 4. So the value of s becomes 7. Right? Now it goes on to the next iteration. The value of I becomes 2. 2 is less than 3, which is correct. And then it goes inside this again. Sum is equal to 7 plus integer.parseInt. So the value of I is 2. 2 comma 3. This is the second index, and comma 3. So the value of this s dot substring will be 7. The string 7. The string 7 gets converted into integer thanks to this integer.parseInt. 7 plus 7 is 14. So we get the value of sum as 14. Now the value of I gets iterated again. I becomes 3. 3 is less than 3. Wrong. It's wrong because it's not. So it comes out of the for loop. And now it just prints the value of sum. It's a very simple basic code which shows how we can use integer.parseInt to make our code more compact. So if I execute this program code over here, the sum of digits, void main, let's add the number 374. The answer is 14. So it perfectly calculates the sum of the digits of the number. So this is how you can basically implement the integer.parseInt, even the double.parseInt, byte.parseInt, character.parseChar, or anything like that. It's a very useful thing, and I use it, personally I use it like almost everywhere in my program codes, because usually while dealing with integers, I like doing it with string because it's much easier, because it's easier to extract each digit of the particular number. So it's very useful in my opinion. And like I say every time, have fun with this parse string functions and the wrapper classes, experiment with it, and get the hang of it so that you can see yourself implementing it in your program codes. So that's it for today, everyone. Thanks for watching, and if you have any queries, doubts, or suggestions, you can mail me. My email will be in the description down below, and thanks again for watching.